Welcome back to my channel, Chill with Maths. As I've already told you, I'm going to upload the videos based on Bsc. So at present, I am going to upload real analysis, that is in your third semester. So the first unit is sequences and series. And then I'll be posting the entire syllabus for you later on. As of today, we'll just move into the theorem, a very important theorem, which says every convergent sequence is bounded. Before moving on to this theorem, I would like to introduce your definition, that is, what is a convergent sequence. So a convergent sequence is a sequence Sn is said to be convergent if it has a limit. Whenever a sequence has a limit, then you can tell that it is a convergent sequence. Or you can even refer it as, for each epsilon greater than 0, there exists an m positive integer such that Sn minus L is strictly less than epsilon for all n greater than or equals to m. Now by using this definition, we are going to solve the theorem. And next, coming to the boundedness. Just remember that boundedness implies if the sequence or the series which has both lower and upper bound, then that is said to be bounded. So now coming back to the theorem, that is every convergent sequence is bounded. So the proof, let sequence Sn be convergent. What is convergent? If there exists a limit. So this converges to some limit L. I repeat, what is convergent? Whenever there exists a limit of a sequence, then that is told to be convergent. So I'm just assuming let sequence Sn be a convergent series which converges to L. Now write down the definition, that is, for each epsilon greater than 0, there exists an m positive such that mod Sn minus L is strictly less than epsilon for all n greater than or equals to m. Now, we have to just take out the mod. If you take out mod, the epsilon lies between minus epsilon to plus epsilon. So this will be minus epsilon less than Sn minus L is strictly less than epsilon. So this will be take L outside. So you'll have L minus epsilon less than Sn less than L plus epsilon. Now we have to show this as bounded. So for bounded, what is that we have to show? We have to show it has both lower bound and upper bound of the sequence. So now coming here, the sequences, you'll have S1, S2, so on up to Sn sequences. Let for all n greater than or equals to m, let this relation be 1. So I'm just assuming or choose K1 is equals to, we'll talk about the left hand side, that is lower bounds. What will be lower bounds? Minimum of S1, S2 and so on up to Sn and this L plus epsilon also. L minus epsilon. Next, choose K2, that is all the upper bounds. So upper bounds are maximum of S1, S2, so on up to Sn, comma L plus epsilon. Now you can take this relation as equation 2. So you can write this as K1 is less than or equals to L minus epsilon and K2 is greater than or equals to L plus epsilon. So let this be equation 2. So from 1 and 2, what is that you can conclude? This is epsilon. From 1 and 2, we can conclude that K1 is less than or equals to L minus epsilon, less than Sn, less than L plus epsilon, less than K2. So this can be directly written as K1 less than Sn, less than K2, where K1 is the lower bound of the sequence and K2 is the upper bound of the sequence. Now Sn has both lower bounds and upper bounds. What is the definition of boundedness? If it has both lower and upper bound, we can refer it as bounded. Therefore, we can say the sequence Sn is clearly bounded. The sequence Sn is clearly bounded. So now let us look into the converse of this theorem. So what does a converse tell? That is, does every bounded sequence convergent? What is the converse? Every bounded sequence convergent or not? Let us prove this by taking a example. So let us take an example which says the sequence Sn is equals to -1 whole power n such that n belongs to some positive integer plus. So what will be the sequence? Either it should be -1 or +1, -1, 1 and so on. So the range of the sequence is either -1 or +1. What will be the infimum of the sequence? Infimum of sequence Sn equals to -1. Supremum of sequence Sn is equals to +1. So here we can observe one thing. This infimum is converging to -1 and supremum is converging to 1. So we can tell that is the sequence Sn has both lower bounds and upper bounds, that is -1 and 1. We can clearly tell that sequence Sn is bounded. Why? Because it has both lower bound and upper bound. But these two are converging to different limits. Whenever a sequence converges to different limits, it is not considered as convergent. This is bounded but is not convergent because it is converging to two different limits. It is converging to two different limits. So we can conclude that every convergent sequence is bounded, but converse is not true. That is, every bounded sequence need not converge. Thank you for watching this video. Please do subscribe to my channel.